When it comes to L'Hopital's rule, we often get very confused and lost about one question. That is, when exactly are we allowed to use L'Hopital's rule? In this video, we're going to clarify this question and give you a counterexample. So basically, we are always allowed to use L'Hopital's rule to find the limit, but that is only when the limit exists. Of course, including infinity. Positive infinity, negative infinity, both of which are counted as exist. However, we never use L'Hopital's rule to conclude limit not exist, which means even if after using L'Hopital's rule, this quotient limit does not exist, even if that, it does not imply the previous limit of the previous function does not exist. And here is a counterexample. We're gonna let f of x equals x squared times sine of 1 over x, and g of x equals x. We're going to calculate the limit in two different ways. The first way, we calculate this limit directly without using the L'Hopital's rule and see what happens. And secondly, we calculate it by using L'Hopital's rule, and then we compare these two answers to find something interesting. Calculate directly. We have limit x approaches 0 plus of this equals x squared sine of x divided by x. Okay, and then we can cancel x, the top and the bottom, so it comes to this limit. It's very easy to see that this limit is 0 because x will go to 0 and the sine function is bounded. If you're not so sure how to prove this is 0, here is a kind of simple illustration. We're gonna start with sine of this thing bounded by 1 and negative 1. And then we multiply both sides by x to have x sine of this less than x, and then negative x. Because x is positive, right? So it does not change the direction of the inequality. And then we see both the lower bound and the upper bound would have 0 as their limit as x approaches 0. So since limit x approaches 0 plus negative x equals limit x approaches 0 plus this x equals 0, we have by the squeeze theorem at limit x approaches 0 plus of the function between also have the same limit 0. So you know this one is 0. We're going to write it down there, and then we will compare it with limit we found later using L'Hopital's rule. So this equals 0 by calculating directly. Next, we will do it with L'Hopital's rule. With L'Hopital's rule, we have same limit xgx equals limit that x squared sine 1 over x divided by x. We see the top function and the bottom function both of which go to 0 as x approaches 0 plus. So let me write that down. We have this limit x approaches 0 plus for the top function being 0, and then the bottom function so I have the same limit 0. This can be shown by using the squeeze theorem, just like before. It's very similar. So what we have here is actually a 0 over 0 indeterminate form that allows us to use the L'Hopital's rule. So we will take the derivative for the top as well as the bottom, then come to this limit, which is 2x sine of 1 over x by using the product rule, and then for the another term you will use the chain rule, that is x squared cos 1 over x, this one, and then divided by 1. Simplify this a little bit. It's going to give us 2x sine this, and then you see this x squared cancel with this, and then we can bring out a negative sign. So write minus sign here. X approaches 0 plus cos 1 over x. What is this limit? We've just calculated this limit in the previous work. This limit is 0. And then for this limit, when x gets very close to 0 from the right side, this fraction 1 over x is going to approach positive infinity, very large number, but cos function does not have a limit at infinity, because the cos function essentially goes up and down, always oscillates in between -1 and 1. So it does not get stabilized as the input gets very large, approaching infinity, which means you're going to have 0 minus cos of infinity, but cos infinity does not exist. So the final answer for this one is not exist when we calculate the same limit with L'Hopital's rule. Okay, so now let's compare this answer to that answer. Why? Of course, they're totally two different answers. Which answer is correct? Of course, this answer is correct, which means that this answer must be wrong. It's wrong not because L'Hopital's rule is wrong. It was because we accidentally neglected to check one condition when using the L'Hopital's rule. The L'Hopital's rule works. L'Hopital's rule is valid only when the final answer, final limit you get, it's a existing limit. It works for like limit, if the limit is a finite number, or if the limit is positive, negative, infinity, it works totally fine. But not in this situation where the limit does not exist. Which means even if this does not exist, you cannot say anything about this limit. Right? Indeed, this limit exists and equals 0, as we have calculated it before. Okay, so this contradicting result is a counterexample of why you never use L'Hopital's rule to conclude the limit does not exist.